is asking you to take kind of a word problem that's just talking about a triangle with certain lengths and make use of the Pythagorean theorem. So it says you've got this right triangle with side lengths of 2x, 2x was 4, and then the hypotenuse is 4x minus 4. So I've actually drawn the triangle out here first, and I would really suggest that you do the same thing so you actually know what you're talking about. The side lengths then you can identify a little bit better over here, and the hypotenuse is 4x minus 4. And we want to take that information and we want to set up the Pythagorean theorem equation and just plug stuff in for it. So I've got a squared plus b squared equals c squared set up, and in place of a squared I'm going to take one of those legs. I chose 2x to go in its place. B squared is going to be the 2x plus 4 squared in its place. So it ends up looking kind of like this. You can see the c squared then ends up being the 4x minus 4 squared. So it's a lot more complex in terms of the numbers and what you're trying to find, but it still ends up still just being an algebraic equation that you can solve for. So you might not have done this in a while. 2x squared isn't that bad. You're going to square the 2 and square the x to get the 4x squared. These other two expressions are going to be using the foiling system, where you've got a binomial that's being squared. So 2x plus 4 ends up being really 4x squared plus 8x and another 8x, so 16x, and then the 4 gets squared to become 16. And the same thing happens over here. That 4x minus 4 squared gives you this entire value over there. So now it's time to start combining things that you can that are like terms, and really the right hand side just stays the same. I just brought that down. The left hand side I've got 4x squared and 4x squared, so they combine to 8x squared, and the rest of that stays the same. Okay? So you've got 3 terms on each side, one that's squared, one that's just x, and one that's a constant. The constants happen to be the same. They're 16. So if I subtract away 16 on both sides, those 16s just go away and the equation is still balanced. So I've got something like that. You've got a couple different options at this point. I chose to subtract away the 8x squared from both sides so that it goes away from this side. And then I added 32x to both sides to get rid of this over there. When I do those two things, subtracting 8x squared gets me 8x squared remaining on this side. When I added 32x to both sides, it goes away over here, but over here I've got 48x. And now at this point I see I can take out an 8, I could take out an x. I'm going to show it to you in 2 separate steps. So if I take out the x first, so divide both sides by x, that's what you're left with. And then if you divide both sides by 8, you've got a value of 6. So 6 is the only value that you could put in place up here where that is truly going to give you a squared plus b squared equals c squared when you plug it in.